Mario once again with MIM Flight. This is going to be a long video on this brushless motor that I just designed and built recently. This is part of the work that I'm doing with brushless motors, my own customized motors, so that I can apply them to some of the vintage Microsoft micro helicopters that I did back in the early 2000s. Back in those days, we used just regular brushed motors, and so I've been bringing some of that stuff, not to sell or not that I want to sell those helicopters. I mean, I did that back in those days. I'm done with that, but more so for my own enjoyment and just to bring my old helicopters, old designs, to direct drive rotors. So I've been experimenting with some rewinding some of the motors that are out there, some of the motors that I had. I rewound a 2204, a 2300 kV motor to drop the kV down to 600, and that seems to be working fine with a 3-ounce helicopter. But my Bumblebee is actually 4 ounces. It's a little bit heavier than my other ones. So I am, this is a proof of concept, if you will, for a for such a motor, that's going to drive the Bumblebee. And so this is just my way of doing this, which is the obvious way to do things. If you understand that the mechanics of brushless motors, if you don't have access to a laminated core, that has to be cut through water jet or laser, and one way to get around that is to do it the way I show here, with these small steel bolts. These are 256 by 3/8 and insulated. I showed that in some short videos that I did earlier, and wound around those screws. And as you can see here, it's working. It's working really nice. This is unloaded readings here: 0.6 amps, 7.3 volts, 4.7 watts. This has a 50 turn. This is, by the way, it's a 12 slot, 14 pole motor, wound for star or Y configuration. The wire is 0.010 inches in diameter, enamel or magnet wire, 50 turns per coil, and basically this is the result of that. Now, my next test, as I said in one of my shorts, is that this motor will have to be mounted, on the helicopter and tested with a 13-inch propeller. I don't think I'm going to do that with this particular motor because it is going to build up heat here. It's a little bit warm at 0.6 amps. I mean, 0.6 amps is it's a good amount of current there. .6 at 0.5 at about 5 watts. So my next step is going to be to make this motor, basically replicate this in aluminum. I'm going to have to turn this on the lathe and do all these perforations. I do have a little mill that I can use. It's set up with a turntable, an indexing turret that I can drill these equally spaced. That way I can come in with the same thing with the 256 screws. I'm going to have to thread that, put some threads there so that it grabs nice and secure, and do the same thing I'm doing here. I am going to make the spacing between the bolts and the magnets a little bit tighter, but that I can do on the aluminum version of this, and that should be a good motor to test it on the helicopter, because it'll be able to hold the heat. At that with a 13-inch propeller, which is what my submicro helicopters use. This is probably going to pull a good 2 or 3 amps. I would suspect that just based on some other measurements that I did with the other rewound motor, the 2205. But I cannot get over how well this is working. I mean, look at that. Also looks beautiful. You know, it's just looking right through the motor as it spins. Yeah, it's so quiet, very, very smooth. So anyway, this is where I'm at with this particular motor and project, and my next one will be hopefully metal, and I'll test. I'll be able to test that on the helicopter. All right, once again, stay tuned for more.